This video will look at those pieces of material that we did not cover in class. The work we did in class is in a video that's out on Moodle. Also, the handout that I'm going to be going through here is out on Moodle. We're going to go through the last part of this handout so that you can complete those and understand those ideas and do the problems at the end of this section. This work will be then due on this coming Monday by noon. So just a quick review. In class, we looked at rectangular coordinate system, the Cartesian plane, what ordered pairs were, how they indicate locations. If you're given a bunch of locations, points on a Cartesian coordinate system, be able to determine what those points are. If you're given the points, be able to make the locations on the plane. Also, we started looking at equations of lines. We said, well, how do we draw one of these? Well, what we did is we went ahead and said that, okay, let's make a table of values, x and y. Put in a value for x, you get a value for y based upon that equation. You plot those points and draw a line through it. Again, we also noted that this, because the value of x and the value for y are both of order 1, in other words, if this is the first power, this is going to be a line. Okay, so we had a variety of different kinds of lines that we looked at. Okay, and then this one here turned out not to be a line because it has a second degree expression in it. So this turned out that we saw something like a parabola with that one. Okay, so what we're going to look at now is we're going to look at the ideas of x-intercepts and y-intercepts. This is with regard to a line. The x-intercept is the value of x where the line crosses the x-axis. The y-intercept is the value of y for where the line crosses the y-axis. So when we look at these, we say, well, how do you figure that out? Well, if we want to find out the x-intercept, that means we're talking about where the line crosses the x-axis. That means that the y has to be 0. If we're going to look at the y-intercept, that is where the line crosses the y-axis, then the x has to be 0. So in order to find the intercepts, we use this information. So first of all, we look at y equal to 0. We're going to take the value y equal to 0, and we're going to go ahead and put it into this equation, and we'll solve for x. So let's go ahead and do that. So go ahead and we say we have 0 is equal to a minus 3x minus 4. We just go ahead and add 4 to both sides. Okay, so we have a minus 3x is equal to 4. And then since we're multiplying here, we'll divide both sides by that minus 3. And we have that x is equal to 4 divided by a minus 3. Or you can just write this as a negative 4/3. So that's what that value for x is. So at the point a negative 4/3 y 0, that is where the line crosses the x-axis. Okay, we do the same thing when we're figuring out where the line crosses the y-axis. Use the same equation as we had before, and what we're going to do is we're going to say, okay, now, since we know y is 0, or x is 0, then we have y is equal to a minus 3 times 0 minus 4. So y is equal to a minus 4. So then that means the y-intercept, that value, is going to be 0, comma, minus 4. So these are the 2 points. One, the y-intercept, the other, the x-intercept. So let's go ahead, and we know if we can draw a line if we have 2 points, and so we can use these intercepts as our points that we use to draw the line with. So let's look at the point of the x-intercept first, which is, if you see up above here, that is the value minus 4/3. So that's a negative 1 and a little bit more, and of course y is 0. So again, we're always going to label everything. Minus 4/3, comma 0. So that's the point. Now what we're going to do is we're going to, that's the x-intercept. The y-intercept is just going to be at a minus 4, so that's down here. And so this is the value of x being 0 and y being equal to a minus 4. Okay. So those are the 2 values we have. And with those 2 values, we can now draw the line. So we'll go ahead and between these 2 points, we'll draw a straight line. I'll draw one as best as I can. And And that is now the line for y equal to a minus 3. Let me see this for a minute. Okay, so we have y is equal to a minus 3x minus 4. That's our equation of our line. Okay, so so here's another example that you can go ahead and work on. Again, x-intercept, you put in 0 for this value here, and then you solve for x. Y-intercept, you go ahead and you take x equals to 0, you put it into there, and then you solve for y. Plot the points, draw a line between them. The next thing we want to look at is the idea of a midpoint between two lines. That means there is a point that is halfway between two other points. In other words, the distance from A to this midpoint is the same as the distance of the midpoint to the other point, B. So let's look at a couple problems to give us an idea of what's happening here. Let's suppose we have 2 points, but they have the same x value. So our value for x is the same in both of these, and that value in this case is 3. So if I want to find out the distance between these two values, I only have to worry about the distance between the values that we have here of 4 and minus 6, and then we would divide that by 2. Okay, so what we're going to see is this. We're going to go ahead and take these two values. We'll take the value of 4. Let me go ahead and change the color on this. It's easier to see. So we're going to go ahead and make this 4 plus a minus 6 divided by 2 is equal to a minus 2 over 2, which is equal to a minus 1. So what does this say? A little closer here. We're saying at the value of a minus 1, which is here, so we have, this is the y value here, y value. So here at a minus 1, we have the value that's halfway between. In other words, this is the value for the y. Let me get rid of this. We don't know that one yet. We know this is what the value for the y is. And if you just look at this, even though we don't have the value for the x, you'll see that if this is 1, 2, 3, 4, 5, and the other one here is 1, 2, 3, 4, 5. So there are 5, a distance of 5 on both sides, because that's the total distance, as you can see, is 10 divided by 2, you get 5. But we are looking for, we know that, but what we want to do is we want to find the point. So we figured out that the x value here for this point is 3, because that's what all the values have to be here. So in this case, we now know that the answer to this, now we know that the answer to this is going to be equal to 3 minus 1. So that's the midpoint. And notice the x value was the same, so it didn't change, just the y value is all we had to find. We're going to do a similar thing here. In other words, in this case, though, our y value doesn't change. Okay, so we have the same y value. So what we want to do here is we'll take the 4, add to it the minus 3, and divide that by 2. Okay, so if we have the value of 4 minus 3, of course that's just 1 divided by 2. Okay, so that means that our value for y, our value for x, our value for x is a half. So if we look at this, let's look at this closer. This is a half. So if we go up here and look at this value here, a half, which is halfway between the two, you say, well, yeah, that makes sense, because between a minus 3 to a 4, that's 7. And if I take 7 divided by 2, I get 1, 2, 3.5, 1, 2, 3. So that's the value right in the middle. And that point is the value of 1/2, comma 1. So that's the distance. Now, if we wanted to do this for any 2 points that aren't lined up like that, what we're going to do is we're going to do what we did for the x values, the x things along the x-axis or things along the y-axis. We're going to do that for the points. This ultimately turns out to be the formula, and we're going to go ahead and look at how it comes about. Okay, so we're looking for the midpoint of this segment, so we want to find the midpoint of this expression here. And again, the 6 value, 6 here, stay the same. So this is 7 plus 1 divided by 2. So that's 8 divided by 2, that's is equal to 4. So that value is 4. Down here, we have the x values are the same. So we take the 6 plus a minus 4, divide that by 2. So what does that give us? That gives us 2 over 2, which is 1. So what that tells me is that the midpoint here is going to be the value 1, comma 4. Okay, so we've got the halfway along this axis, and this is halfway along this axis, and this then gives me the point 1 minus 4. So if the 1 goes there, minus 4 goes there, that gives us our point. Okay, and the rest of this here, it just indicates what I just said. You add the values for the x value here and here, divide by 2, you'll get that first coordinate for that value. And then you do the same thing for the second value. And then finally, we end up with our point, which we just indicated is 1, comma 4. Now, we want to go ahead and see what this looks like when we go ahead and just use that formula. And basically, all this formula is really doing is this. It's figuring out what this value is, which is that value right there, figuring out that, which is this. And this part of the formula is the 7 plus 1 divided by 2, which gives me this part. So this is the part you work with the x values. So you've got 2 points. You got one of the points, this one up here. Let's refer to it as the point that's x1, x2, y2, and we'll call this one x1, y1, and that will correspond to the components of this. So in the first one here, if we have x2 minus x1, which is what the formula says, that would be saying 6 plus a minus 4, and that is going to give us the value that we had right here. So in other words, this value here was the x2 plus this value here is going to be the x1. And then you divide those by 2. Okay, so that's basically how you do the midpoint. Again, there'll be some problems at the end here. You should go ahead and practice doing this. That next idea that we're going to look at is called the distance between 2 points. So suppose we have 2 points like this, but this is going to be based upon something that you've probably heard of. It's called the Pythagorean theorem. It's based on the idea of a right triangle, which says basically if you take one of the adjacent sides and square it, and the other adjacent side to the right angle, square it. You add those together, you'll get the square of the c value, which is the hypotenuse. And that's what we're going to be using in this problem. So in this particular case, these are our points we're talking about, and this is the distance we want to find. So let's look at that, and we'll say, okay, we want to find the a value for the right angle and the b value. So how do we do that? Well, the way in which we do that is we go ahead and figure out what this distance is from here to here. That would be the value of a. And notice the y value here does not change. In this case, it's a minus 2, minus 2. So the value that we're talking about is here. So we want to figure out what that distance is. So what we're going to do is we can take the x2 minus a minus 4. That gives me a plus 6. And that would give me this value here then as being 6. So let's look at that. This is what we're doing specifically. Again, these values here, here, and here, they don't change. The only things we're looking at are those values. That gives us the value 6. We do the same thing to figure out what b is. Figure out the distance of the 6 minus the minus 2. That gives me 8. So that means that this distance here is 8. Okay, so now we have the change of y value, and we have the change in x value. And those are the values we're going to put into our distance formula. So we just go ahead and we'll write down what this looks like. Again, we use the Pythagorean theorem is in here. We're taking the square root of a squared. Well, what's a squared? In this case, that would be 6 squared, plus the square root, or plus the square of the 8. And together, when we do this, this is the square root of 36 plus 64. That's the square root of 100. and that's equal to 10. So what that tells us is this, that this value here, the distance, is equal to 10. Where the one side is 6, the other is 8, so that's the distance between those 2 points using Pythagorean theorem. This is another problem. You should go ahead and do this. It's the same idea. You'll get used to using the formula. And then finally do this problem as well. Okay, then there's some exercises at the end here I want you to complete. So go ahead and complete this handout with these problems, and then turn them in by noon on Monday. So I will see you at 3 o'clock on Monday afternoon.